As a lot of you know, I used scavenged materials to make a lot of my knives. I use saw blades, files, or in this case planer blades. The planer blades make a good knife. They're hard. I'm not sure of the steel on it. It's marked, but I have not been able to find the markings anywhere. I had a friend tell me it could be D2, could be M1, could be M2. I did anneal a couple of planer blades and then hardened them as I would have hardened D2 for the temperatures of D2. My heat treating oven doesn't get much higher than that. I cannot heat treat to the specifications that I need to for M1 or M2. My oven just doesn't go that high. And it turned out pretty good. But that's just an extra step that, you know, sometimes I don't feel like taking. So my grinder has no problem, or my angle grinder has no problem cutting it if I want to cut this off and make a blade. And then my grinder has no problem profiling it and grinding it. Yeah, I'll wear out the belts a little bit faster, but that's okay. But I cannot drill it with my carbide bits. These do need to be tempered because they're probably pretty brittle to draw some of that brittleness out of it. But take that blade, cut it to size, profile it, and grind it, and you end up with that. I'm not done with this, obviously. You can see how thick it is on the edge. But that's out of the planer blade. But as you can see here, for an 1/8 inch hole, I'm just not getting through it. So, came up with the idea of let's heat this up and try and anneal just the tang part of it, but then what about the blade part of it? I don't want to change the temper on that. Got the brilliant idea, if it works. If it didn't, not so brilliant, to try and use this. It's made by Lacco. It's called Block It. It's heat absorbing paste, and it says on the tube, protects against damage caused by heat from soldering, brazing, welding, easy to use, non-toxic, blah blah blah. So the theory is I will coat from about here to here with the paste and then heat up this with a torch and we'll see what happens. So I'll get that set up and we'll find out together. Okay, as you can see, I've got the paste put on the part that I don't want to change the temper on it, and let's see what happens. And we'll let that cool off and see what happens. Alright, it's obviously cool to the touch. The paste looks like it flaked, dries out, but there's no discoloration on the blade, so that looks promising. Let's see what the back side looks like. It comes off pretty easy, and there's no discoloration at all to the steel in the areas that I did not want affected. So let me take it to the drill press and we'll see how it drills. Now with the carbide bit in here, let's see what happens. as you can see, gets the job done. I mean, it's not quite as good as annealed steel. It did soften it up some, so I guess technically that's annealing, but I mean, doing it in the oven, doing the whole blade, and doing it properly, letting it cool down slower. Possibly, if after heating a blade, put it in vermiculite or something to have it cool down slower than just air cooling like I did. Might work better. But this worked enough to get the job done. And for me, I mean, when I heat treat D2 steel, okay, for the annealing process, you heat it up 600 or 700 degrees, 800 degrees, and then let it cool down slowly. That's 6 hours there. And then heat treating it, taking it up to 1875, and then quenching it. But then, now D2 is an air quench steel. It's not a liquid quench, but quenching it, but then the oven's got to cool down. I've only got one oven, so then when I temper it, because after I harden it, I don't do anything to that steel until I temper it because it's very brittle. I temper it at 500 degrees for 2 hours, and I do that twice. So from 1875, those fire bricks have got to cool down. I let them get down below 100 degrees, and that takes some time. That takes quite a lot of time. Then again, from cooling it down from 500 degrees to below 100 degrees for the second cycle, again, that takes time. So, you know, we're into another day and a half, or day and a half. So, I mean, this has taken 2 days off the process of making a knife. I mean, not that I'm ever in a hurry when I make one, but just thought it'd be something I'd try. Don't know if it's something I'll continue to do, but maybe. I know for making a hidden Tang knife, for drilling that one hole, this would come in handy. Drilling any holes come in handy, but that might be something I continue to do. We'll see how the knife performs. Thanks for watching. You know, I was thinking about this process, and, you know, it works. But I think where this process would come in especially handy is if you don't have a heat treat oven. Because if you remember, I said D2 steel is an air-cooled steel. It's not a liquid quenched. It's an air-quenched steel. And I can't dig this stuff out now, but I think I've done a video on heat treating D2 steel. But basically, you put it in a stainless steel foil packet, heat it up, and then I clamp it between two big pieces of aluminum here, and within a few, like 30 seconds, it's cool enough to the touch. So it goes from 1875 down to pretty cool fairly quick. But if you don't have a heat treat oven, that thing that's under that black plastic right there, this would be pretty handy, where you don't have to change the temper of the whole blade, and you can still get your holes in it. Just thought I'd pass that along.